Now let's discuss IP tables with IP version 6 implementation. There's a separate package which is included with this version of Red Hat Enterprise, which has the tools necessary to invoke and manage IPv6 filtering or firewalling. We'll clear screen in RPM, query all grep I, IP tables, where you'll see two packages, including the version for IPv6, which includes its modules which get loaded whenever IPv6 IP tables is started. An RPM query list of IP tables IPv6 reveals those modules that I've just mentioned, and also reveals that, like IP version 4 tables or IP tables, IPv6 tables has an initd entry, which means it starts or is configured via init.d or initialization.d directory, which means you can start, stop, restart it. It also means that it reads a general system-wide configuration file beneath etc sysconfig ip6 tables-config. So in other words, it's set up similarly to IP version 4 IP tables. So let's label this subsection IPv6 IP tables. Features include firewall for IPv6. And these are some of the key files. This is a start script or control script, run script, and this is the system-wide config file, which determines whether or not IP6 tables saves its configuration upon stops as well as restarts, as well as how it behaves when it starts. Let's take a brief look at some of the other included items. For the different functionality provided by IP6 tables, there's a module included such as connection marking, rejecting, which is a target, marking packets, logging packets, queuing packets, as well as EUI64 parsing, as IP6 or IP version 6 makes use of EUI64 addresses, which incorporate 48-bit MAC addresses, which can be found on every Ethernet network adapter. ICMP version 6 MAC addresses under IPv6, although it's a layer below in layer 2, and other important items for TCP, UDP, policy, physical devices that get created, and three primary tools used to maintain the IPv6 tables environment. These tools are similar to the tools used for IP version 4 IP tables. This is the primary tool for administering IP6 tables. And just like with IP version 4 IP tables, we have a tool to restore rules and one to save rules. Now, just for a brief moment, let's take a look at the startup file so that you can get a sense for the items that are configurable. We'll execute less, followed by the full path, and as you can see, it includes similar options to IP version 4 IP tables, such as any modules to load, separated by space, whether or not IP6 tables are to be unloaded, the modules, that is, are to be unloaded whenever IP6 tables has been stopped or restarted, whether or not the rules are to be saved when IP6 tables is stopped, ditto for restart, whether or not the counter information is to be saved. The default is no, which means any counters associated with rules that are defined will be discarded, and other settings that we've seen in IP version 4 IP tables. Now, as it stands, IP6 tables is not running. We can confirm as such using etc initd IP6 tables status. This should tell us that the firewall is stopped. We should also note as a feature that IP6 tables maintains three default tables. But unlike IPv4, one is different. They include filter, which matches IPv6 to IPv4, mangle, which also matches both implementations, And instead of a NAT table, as network address translation is unnecessary within an IPv6 environment because there are more than enough addresses to go around for each and every device connected to the internet, there is a table named raw, which is used to manipulate raw packets within IPv6. These are the 3 default tables that can be configured, and each of these tables have varying numbers of chains which can be further configured to store rules that are applicable to the traffic patterns that you're attempting to match. So as far as general usage is concerned, a simple IP6 tables for the main utility. Upper L will list the default table just as it does with IP version 4. This is the filter table, which includes input forward and output chains, just like with IP version 4. This table affects traffic into, routed through, and sourced by or out of the local system. So treat the filter table just like you do within IP version 4. We'll just note that it matches IP tables for IPv4, just to be clear, and you should treat them identically, with the lone exception of course being that you'll indicate IP version 6 addresses, 128-bit addresses, as opposed to 32-bit IP version 4 addresses when writing rules. So simple IP6 tables dash list, or upper L, will list the default filter table with its included chains. If you'd like to take a look at the other tables, use the T option, lower T followed by the name of the table, such as the raw table, and this will list the contents of the raw table. The raw table contains pre-routing and an output chain. Ditto for mangle. And it was misspelled. And there we see the mangle table has the same number of chains as you'll find with IP version 4. So they're used similarly, but again, the IP6 tables utilities allow you to specify version 6 addresses as opposed to version 4. Which leads us to the next point, and that is to be able to write rules for IP6 tables. So rather than basic uses, let's just jump into some simple tasks, and we can copy the tasks that we've defined from the IP version 4 videos, or video that is, section, and repeat them here. This will become what we attempt to get done with IP6 tables. So, filter inbound traffic to the remote system to SSH and drop everything else. So instead of IP tables, or in addition to IP tables, we'll indicate IP6 tables. What this means is you need to administer your IP6 rules independently of your IP4 rules. We should just note that. Note, IP6 rules, or IPv6 rules, are administered independently of IPv4 rules using the appropriate utilities. So our first task is to filter inbound traffic to that remote system using IP6 tables. Just like with IP version 4, you can indicate that you'd like to append a rule into the input chain of the filter table with a protocol of TCP, which applies to IP version 6 as well, destination port of 22, and a jump target of drop or accept. This should be accept followed by a drop target. And we should correct our notes for the prior section because this is indeed not what we typed at the command line. It was accept, then the last rule or the next rule in the input chain of the filter table was a drop rule. So here's a simple rule. IP6 tables, let's copy it by simply changing IP tables to IP6 tables to see how the remote system responds. And notice it responds. Let's rerun IP6 tables with list, upper L, where you'll find one rule. So just like with IP version 4, you can apply a rule, especially when you don't have to indicate a specific address, by using generic items such as protocol, destination port, without indicating options, source, or destination items. So this will accept SSH traffic for IPv6 and nothing else. As a case in point, if we were to execute ifconfig to ascertain the IP version 6 address of the remote system, we see it's 2002 leading up to 1692. From the local system, we should be able to communicate with this address using ping 6, sending 3 packets to the remote system. We see that it responds. However, momentarily when we include the drop rule, we'll see that ICMP traffic, or ICMP version 6 traffic, will not be returned. So let's include the ICMP drop rule, which is also a rule for other types of packets with the exception of SSH on the remote system, that is. And then relist the rules for the input chain of the filter table, which reflects that it will accept SSH and drop everything else. Now locally, let's try to ping again, and notice we're getting no ICMP version 6 replies, and that's because of the drop rule, the secondary drop rules. And just like with IPTables, IP6 tables supports numerous options, including the ability to consult the counters or to enumerate the counters, to turn on verbose mode, to list chains within tables and to focus on specific tables using lower T, to indicate a jump target, to specify source or to negate a source, to specify a destination or to negate a destination, even to specify a distinct interface, as we see below, using lowercase I or a long option in dash interface. And again, we've looked at enumerating the counters for packets in the prior section for IP tables using the verbose option. So for example, IP6 tables list V will return counters which will show the number of matches to the drop packet rule or the drop all rule. And if we send some more traffic, 632 will increase to a greater number over the duration of the ICMP version 6 attempts. So we see that traffic's being dropped, and we also see that no traffic has touched the IPv6 SSH rule. So for example, let's take a look at our IP version 6 address again, copy it into memory and attempt to SSH to it from a local shell using Control-Shift-T. SSH --help returns the options that are possible. Using 6 will enable connectivity to a remote system using IPv6, followed by its IP address, IPv6 address that is, and this will try to set up a session to this particular host. And let's try it again. And we'll see momentarily that it'll come back asking us to connect to the remote system. When connecting using an SSH client, use the -6 option. And also, if there are any issues with the rules that can prevent you from connecting, just double check to be sure that the rules permit IPv6 connectivity to the SSH port. We'll just give this a second to come back, a few seconds to come back. And there it prompts us for the password. And we attempt to log in as Linux CBT, which it isn't taking, so what we'll do is just kill the session altogether since the server has responded, and indicate root at the remote system's IPv6 address, which permits us connectivity to the IPv6 address as opposed to the IP version 4 address. So again, just like we've seen with IP version 4's version of IP tables, IP6 tables works similarly. Again, one of the lone standout exceptions is the lack of a NAT table, because IP6 or version 6 provides enough addresses in the 128-bit space to facilitate unique addresses for each and every connecting device. Now we have an IPv6 connection, and netstat ANT grep22 should reveal the v6 connectivity on the SSH port. So it allows us into the system. And just like we did with normal IP tables, if you'd like to flush the rules in IP6 tables, simply execute IP6 tables, flush, upper F that is, the name of the chain that's a part of the default table. If you want to flush a different table, then indicate the table using the T option, and when you follow that up with an IP6 tables list for the table input, we see that in this case, the table filter that is, for the chain input, we see that no rules are defined, so we'll have to redefine the rules in order for them to stick. Now let's just history grep IP6 tables to get those rules. And we see that there is a rule at 1056 in the history, so we'll indicate 1056 as well as 1059, and then rerun IP6 tables list, where we now have the two rules. Now with regard to backing these up automatically for subsequent reuse, let's nano etc sysconfig IP6 tables -config and set the save and restart to yes, such that if IP6 tables starts when the system starts, the rules will be saved if we stop the service or restart the service. We'll save the changes. And by the way, since IP6, just like IP tables, which we didn't discuss, are both located in init-D, these are items which can be set up using checkconfig and can be confirmed using the same tool. Checkconfig list IP tables will reveal whether or not the service is set to start in any of the run levels supported. Ditto for IP6 tables. It's set to start. And at this point, if we execute IP6 tables, status, it tells us the current status, that rules are running. By invoking IP6 tables or IP tables, you effectively start the service. Whether or not the service saves your files or honors the settings that are at etc sysconfig, IPTables-config, or IP6 tables-config depends on when you place the entries into the file relative to when you started the service. So had you placed an entry before starting the service would honor the settings found in etc sysconfig and the corresponding file name. With that said, let's execute IP6 tables stop, and notice it tells us that it has saved the rules to this file, which is exactly what we expected because we modified the item, the sysconfig IP6 tables-config item. A less of this rules file will reveal the rules that are to be reinstated when IP6 tables is restarted. And at this point, since we've disabled the rule, notice, by the way, that the counters are set. If we execute IP6 tables-list, we see nothing's in effect. However, an IP6 tables start will reinstate the rules and load any necessary modules. So lsmod grep IP reveals the various modules. Just like with IP version 4, we have modules for IP6. One for the filter table, the raw table, and the mangle table. One for IP6 tables for its overall management. Connection tracking and other items pertain to IP. This IPv6 that you see here is simply the kernel's hook to allow it to understand the IPv6 addresses that we see when we execute ifconfig for our hosts. So again, writing rules is really straightforward. Simply use the same syntax that you'd use with IP tables, but substitute IP version 6 addresses for IP version 4 addresses. And with the lone difference being that IP6 addresses are longer. Everything else for the most part will work the same since the ports are the same 16-bit range, and most of the traffic that you'll manage using IP version 6 is the same as IP version 4. Again, when our system reboots, it'll reinstate the rules, or if you restart a service, it does so just like with the IP version 4 IP tables. And just like with IP version 4 IP tables, we can back up using the save command and restore using the restore command. So for example, IP6 tables list shows the two rules that are in place at this stage. IP6 tables save will tab it out, dumps the output to standard out, which allows us to use output redirection to send it to a file, and we'll call it IP6 tables rules. And now this file may be used at any point on our local or remote system, because the rules are generic. They don't contain specific IPs. They're simply ignoring source and destination addresses, focusing on TCP port, destination port 22. And just like we did with IP version 4, if you want to filter outbound traffic, apply your rule to the output chain of the filter table using IP6 tables, that is, plural, and a drop for destination port of 22. Let's try this out locally as opposed to remotely and confirm whether or not we're able to connect across the wire using SSH with IPv6. So as it stands locally, IP6 tables list shows that there are no rules defined, so this will include a rule which states that we cannot connect outbound using IP6 as a protocol and SSH, or SSH as a protocol with IP6. So with that said, let's relist. There's a rule, and let's attempt to connect using SSH6 and the 2002 routable address of the remote system. We'll use ifconfig to extract that. And by the way, this is a good use of awk. We could ifconfig and grep inet6, then grep 2002, for example, which would return that line. Then we could send the output into awk and print the, in this case, this is the first, second, so it would be printing the third field, which extracts the final address. And we could further awk and tell it the delimiter is / to get just the IPv6 address out of the pack without its prefix, its 64-bit prefix. And by the way, just for those of you who are not so familiar with IPv6 addressing, the /64 denotes that the first 64 bits represented in hex notation, or the first 4 blocks of 16-bit fields, 2002 4687 DB253, represents the unique network address of our host. This is the unique network prefix. The remainder of the address, or the remaining 64 bits, 20C, 29FF, FE, which is the EUI64 address, B51692 remains, or represents the remaining 64 bits of the network adapter's address, which makes it unique because it's tied to the MAC address of the host. If you take a look at the MAC address here, 00C, 29B5, we find that embedded in the address space here, but it's padded with FFFE to form the EUI64 or 64-bit compliant address, as MAC addresses, as we see above, are 48 bits. In this case, we see 6 parts, 8 bits each, whereas with IPv6 addresses, we see 6 parts, 16 bits each, for 128 bits, as opposed to, and that is to correct 8 parts with 16 bits each. So we see the first, second, third, fourth, fifth, sixth, seventh, eighth, each 16 bits, whereas a MAC address represents, as we see, 6 parts, 8 bits each. So a MAC address that's burned in, as the term goes, to your network adapter is a 48-bit address, but EUI64 requires 64 bits, which is why there's a padding of FFFE, which separates the third and fourth bytes of the MAC address. So we see 000C, 29 interspersed FFFE, then we see B51692. So again, the first 64 bits denotes the unique prefix, the unique IPv6, and this is a globally unique IPv6 address, which allows 2 to the 64 for hosts on the third subnet, and it allows us 16 bits for subnet. So we can define internally with this one globally unique address 65,530 something networks with 2 to the 64 hosts per network. So in other words, there are a lot of addresses that we can assign and will cover us for the foreseeable future. And IP6 tables allows you to write rules using these addresses, and many of the utilities within the Linux environment, such as SSH, already provide support for IPv6 addresses. So on the output side, we're unable to SSH if we attempt. Let's copy the address and just try it very quickly. We'll SSH 6 outbound, and that's going to be from the local system, not from the remote system. And this will be blocked as expected because, again, before we got into the long talk about IP6 addresses, we wrote a rule on the local system, that is, preventing us from sourcing SSH connections to the remote hosts. So you can write the rule this way. You can flush the rule by just changing or substituting 6 or interspersing 6, and you can save your rules using IP6 tables into a file named IP6 tables if you'd like, or modify the default configuration file located in etc sysconfig IP6 tables-config to save the files for you. Now to restore the rules, IP6 tables restore and the name of the file, after we've flushed it, of course, or have lost it for whatever reason. So on the remote system, let's IP6 tables flush, and then we'll follow that up with an IP6 tables list where you see no rules are defined. IP6 tables restore, followed by the file that we saved, followed by IP6 tables list will do the trick. And we'll execute that IP6 tables, and there we see the rule has been, the 2 rules that is, have been incorporated into the input chain of the filter table. So again, no NAT table with IP6. NAT is not required with IP6. And you have mangle, filter, as well as raw tables, and you can interact with the filter table, which is where you'll do most of your work, just like you would with IP version 4. So whatever you've learned for IP tables for version 4, you can transfer it by and large to IP6, minus of course the way you denote or specify IP version 6 addresses. So that's a little bit about how you use the IP6 tables utility to filter inbound and outbound traffic, and a little bit about how it works in general.